So we will start today electrochemistry. Okay, what is electrochemistry? Aditi, you have an idea what is electrochemistry?
Yeah, one like the batteries and the cells.
In this, we will study batteries, about cells. So, what is electrochemistry? It is a branch of chemistry which deals with the energy changes, electrical energy to chemical energy to electrical energy. So, here in this chapter, we will study mainly 4 topics. One is electrochemical cell. This chapter has 4 topics: electrochemical cell. Second is electrolytic cell. There is a third part in the chapter, conductance. The fourth part in this chapter, batteries. So this chapter has total 4 parts. Then totally these 4 parts are totally different. So electrochemical cell, electrolytic cell, conductance, and batteries. So this chapter we will start with the electrochemical cell. Arjun, you know what is electrochemical cell?
No idea.
No idea. So what is electrochemical cell? It is a cell, or you can say substance, which converts chemical energy to electrical. It's ulta, electrochemical, chemical to electrical. The cell which converts chemical energy means energy produced from the chemical reaction. Chemical energy to electrical energy. The energy produced from the chemical reaction is converted into electrical energy. So that is the electrochemical cell. Pradhani, can you tell me, will it be for spontaneous reactions or for non-spontaneous reactions? It is converting energy of the chemical reactions into electrical. So the reaction should be spontaneous or non-spontaneous?
Mom, I think it's going to be spontaneous.
Reaction. This is for spontaneous reaction. And the value of delta G for the spontaneous reaction is always negative. Delta G, and last year you have studied in thermodynamics, Gibbs free energy change for a spontaneous reaction is always negative. These are the important MCQ points for electrochemical cell. And the last point for electrochemical cell is anode is always negative and cathode is positive for electrochemical cell. In electrochemical cell, anode is negative, cathode is positive. Now, before starting with the electrochemical cell construction and all, I will explain one thing, which is redox reactions. Shivani, what is redox reaction?
Reduction and oxidation.
Reaction in which reduction and oxidation takes place. Aditi, what is reduction? What is oxidation?
Reduction is like when you're removing hydrogen and adding oxygen, and like the gain of electrons.
Gain of electrons. That is the main thing. Reduction is gain of electrons. And oxidation is always loss of electrons. So gain of electron is reduction, loss of electron is oxidation. and the reaction in which both reduction and oxidation takes place, that is redox reaction. Let us suppose if I am writing one reaction, zinc plus copper 2 plus gives Zn2 plus copper. Arjun, can you tell me in this which species is oxidized and which is reduced?
Zinc oxidized.
Zinc is oxidized and copper is
Reduced.
reduced. If there is an increase in the oxidation state, it is reduction, oxidation. If decrease, reduction. Zinc is converting into Zn2 plus by losing 2 electrons. So that is oxidation. Copper 2 plus is converting into copper by gaining 2 electrons. It is reduction. And this reaction is redox reaction. And one more thing you need to remember, that is for both electrolytic and electrochemical. At anode, always oxidation takes place. A is anode, O is oxidation. A and O both are vowels. So at anode, always oxidation takes place, and at cathode, always reduction takes place. Anode is negative, and oxidation takes place at anode. A and O both are vowels. You can remember like this. At anode, always oxidation. At cathode, always reduction. Dhanya, in this reaction, which species is oxidized?
Mom, N1 2 N1 2.
Nickel, Ni. Ni2,
Ni.
Ni2 plus. Nickel is oxidized
Oxidized.
and
And
silver is
Ag is reduced.
reduced. And which is anode here? Nickel or silver?
Mom, nickel is anode.
Anode is nickel because oxidation takes place at anode. And silver is cathode. What is the oxidizing agent in this reaction? The species which undergo oxidation is reducing agent, which undergoes reduction is an oxidizing agent. So what is the oxidizing agent in this?
Did you ask me? Because my internet is. Oh, sorry. The oxidizing agent is Ag.
And reducing agent is
Ni.
Ni. So here oxidizing agent is silver and the reducing agent is nickel. The species which undergoes oxidation is a reducing agent and which undergoes reduction is an oxidizing agent. So this is one general thing. What is redox reaction? What is oxidation reduction? What is oxidizing and reducing agent? And which thing takes place at anode and cathode? Now we will start with the main electrochemical cell. The construction of electrochemical cell is there are two beakers. In one beaker, we will take zinc sulfate solution. This you have studied last year also in redox, I think. Zinc sulfate solution. In another beaker, you have to take 1 molar copper sulfate solution. 1 molar copper sulfate solution. Zinc rod is dipped in zinc sulfate. Copper rod is dipped in copper sulfate. This is zinc electrode and this is copper. Both are connected with a wire having key and voltmeter. And both the solutions are connected with a U-shaped tube which is called salt bridge. This U-shaped tube is called salt bridge. So I will repeat the construction. We have two beakers. Electrochemical cell is always constructed in a two beakers. In one beaker we have zinc sulfate, another beaker we have copper sulfate. We dip zinc in zinc sulfate, copper in copper sulfate electrode, and then they are connected with a wire and both the solutions are connected with a salt bridge. Now what is salt bridge here and what is its function? Salt bridge is a U-shaped tube containing KCl or KNO3 mixed with agar-agar jelly. Agar-agar jelly is just to make it semi-solid. Mainly it contains an electrolyte KCl or KNO3. KCl or KNO3 is there in the salt bridge. Now what happens in this case, when you combine zinc and copper, the reaction is spontaneous. Zinc is anode here and copper is cathode. So the oxidation takes place at zinc. Anode pe always oxidation. When you combine zinc and copper, zinc will undergo oxidation. Oxidation means loss of electron. It loses 2 electron and converts into zinc ions. The zinc electrode undergoes oxidation. It converts into zinc ions and loses 2 electrons. From here, the zinc ions goes into the solution and this electron flows through the outer circuit and it reaches cathode. So zinc undergoes oxidation because this reaction is spontaneous. It takes place on its own. So zinc starts undergoing oxidation. The zinc electrode converts into zinc ions and electron. Zinc ions goes into the solution and electron flows through the outer circuit and it reaches cathode. So what happens at cathode? Initially you have in copper sulfate solution which has copper 2 plus ions and SO4 2 minus ions which are equal in number, copper sulfate. So these electrons which comes from anode, it will take up by copper ions in the solution. Copper ions which are present in the solution in the form of copper sulfate, it takes up the electron given by the zinc side and converts into copper. So this copper starts depositing here. So copper ions from the solution gains the electron and converts into copper which get deposited at the electrode. So that is the working of the electrochemical cell. Zinc undergoes oxidation, copper undergoes reduction which starts depositing at the electrode. Now what is the function of salt bridge here? Aditi, you tell me, on the left beaker anode side, in the solution, the concentration of which ion will increase?
I'm on the left side.
Sorry?
My internet is really bad. Can you repeat what you were saying?
The question, my question is, after some time, the concentration of which ion will increase in the anode side? Anode side, zinc is converting into zinc ions. So the concentration of which ion will increase in this side?
The zinc.
Zinc. Your internet is down or there is a problem in this?
No, I'm not.
It's your internet. What about others? You can hear me properly? Arjun, Pradhanya, you tell me. Because today I have changed the side. Maybe.
Yes, ma'am.
You can hear me properly, right?
Yeah.
Okay. So zinc is converting into zinc ions. So after some time, the concentration of zinc ions will increase in this beaker. And which ion concentration will increase in the cathode side? Initially, you have equal number of copper ions and sulfate ions. Copper ions are converting into copper. So the concentration of sulfate ion will increase on the cathode side. So after some time, the concentration of zinc ions increases on anode side and the concentration of sulfate ion increases on the right side. So when these ions concentration will increase, the cell stops working after some time because the solution will not become neutral. So that is the function of salt bridge. To neutralize this positive ion, salt bridge gives its negative ion on this side. It gives chloride ion to the left side so that zinc ions gets neutralized. And it gives K plus ions to the right side of the solution so that excess sulfate ion gets neutralized. So the function of salt bridge is to maintain the neutrality of the solution on both the sides. That is a function of salt bridge.
Can you just repeat that? I'm sorry. I got disconnected.
No problem, I will repeat it. What is the function of salt bridge? When the reaction takes place, zinc is converting into zinc ions, which is going into the solution. So the concentration of zinc ions starts increasing on the anode side of the beaker. In this side, concentration of zinc ions will increase. And the right side, initially you have equal number of copper ions and sulfate ions. Copper ions is converting into copper by gaining electrons. So the concentration of sulfate ion will increase on the right side. To neutralize these two ions on both sides, salt bridge give its negative ion to the left side so that excess zinc ions gets neutralized, and it gives K plus ions to the right side so that excess sulfate ion gets neutralized. Because if solution is neutral on both the sides, then only the cell will work.
Okay, thank you.
This is the function of salt bridge. First point is it maintains neutrality on both sides. Just a minute. Sorry. So that is a function of salt bridge. It maintains the neutrality on both sides so that the cell keeps on working. The second is it completes the circuit. What do you mean by it completes the circuit? See, both the electrodes are connected with a wire, and when you connect both the solutions with a salt bridge, you can see the circuit is complete. So these are the two functions of salt bridge, and these functions are very, very important. So briefly, I will revise this point. Okay, what is this? There is a construction of electrochemical cell. When you combine zinc and copper, zinc undergoes oxidation. It converts into zinc ions, which goes into the solution. Electron flows through the outer circuit, which is cathode. So these electrons are taken up by the copper ions present in the solution and converts into copper. So after some time, the concentration of zinc ion will increase on left side, sulfate ion will increase on right side. To neutralize that, salt bridge give its negative ion to the left side and positive ion to the right side so that the solution becomes neutral on both the sides. And the second function of salt bridge is to maintain the to complete the circuit. Any doubt till here? Tell me. Shivani, you can hear me properly?
Yes, ma'am.
Okay. So that is
Ma'am,
the first.
why is Cu like not like why is Cu not in excess? Why is SO4 in excess?
See, initially you have equal number copper sulfate. Let us suppose you have 10 copper, 10 sulfate ions, right?
Yes, ma'am.
When the electron comes from this side from the anode side, what happens? These copper ions start gaining the electrons and it converts into copper. Now, out of 10, you can say this 4 copper ions converts into copper. Now you will get 4 copper ions and sulfate ion, how many will be there? 10.
10.
So sulfate ion becomes more as compared to the copper ions. So negative charge becomes more. Actually, you have 10,
Understood,
10.
ma'am.
Arjun, any doubt here?
No, ma'am.
Okay. So when current is, now I'm coming to the next point. When current is flowing through a circuit, you know that there must be some potential difference. So we have put some voltmeter here. What is the function of this voltmeter? It measures the potential difference across the ends. Because if there is a potential difference, then only the current flows. And it is found that the electrode potential of this cell is, this is value specifically for this cell. Electrode potential of this cell is equal to 1.1 volt. Electrochemical cell is also known as galvanic cell. And its value is measured as 1.1 volt. It's the potential difference across the ends. Because of this potential difference only, the current is flowing through the circuit. Now another question, Arjun, you tell me what should be the direction of current here? Electrons are flowing from zinc to copper. So direction of current?
Will be opposite.
Yeah. It should be from?
Copper to zinc.
Yes. Direction of current is always opposite to the direction of electrons. So direction of current is always opposite to the direction of electrons. So it should be from cathode, which is copper, to anode. Electrons are moving from zinc to copper. Current ka direction is from copper to zinc. Another 3 marker question which is very important. If I apply some opposing external pressure voltage, if opposing external voltage, opposing means in the opposite direction, greater than 1.1 volt is applied, then what happens to the direction of current? Shivani, you have to try this answer. The potential difference in this case is 1.1 volt. If I apply some opposing voltage of, of magnitude greater than 1.1 volt, then what happens to the direction of current?
Won't it change?
Change.
Opposite.
Yes. The direction of current gets,
Go opposite.
yes, reverse, get reversed. It flows from anode to cathode. So if we apply opposing external potential of magnitude greater than 1.1 volt, then the current of the direction of current gets reversed. Then the current starts moving from flowing from anode to cathode. And this cell becomes electrolytic cell. I will explain what is electrolytic cell. It becomes electrolytic cell. Anode, zinc becomes cathode and copper becomes anode in this case. So if opposing, highlight these 3 points, it is very important, and sometimes these points comes for 3 marks in exam. If opposing external voltage is greater than 1.1 volt, the direction of current gets reversed. It starts flowing from anode to cathode. Pradhanya, you have to tell me the second point. If opposing external voltage is equal to 1.1 volt is applied, then what happens to the direction of current?
There won't be any change.
Good. If it won't be any change means there will be no current, or current remains in the same direction?
Current remains in the same direction.
No. Because there is a potential difference of 1.1 volt, the current is flowing. If I apply some external voltage of 1.1 volt in the opposite direction, it means now
Then it
there is
becomes
no,
zero.
it means there is no potential difference, so no current flows. No current flows. The cell stops working. If we apply external voltage of magnitude greater than, equal to 1.1 volt. Now third, if opposing voltage is less than 1.1 volt, then current flows in the same direction. Voltage is less than 1.1 volt is applied. Current flows in same direction. These are the 3 points when external opposing voltage is applied. This is the construction of electrochemical cell, function of salt bridge, what is the direction of current, and what happens if opposing external voltage of this thing is applied. Write down these points, then I will explain the next thing in this, which is the representation of the cell. If you have any doubt in this, so here one topic is complete, then tell me, I will repeat that. Any doubt here?
No.
All of you are done with writing part?
Yes, ma'am.
Now next is representation of a cell. How to represent a cell? First I am writing the same equation, zinc plus copper 2 plus gives Zn2 plus copper. Now in this case, how to represent the cell? First thing you should know what is anode and cathode. Zinc to zinc plus, you know that it is oxidation, so it is anode. Copper 2 plus to copper is reduction, which is cathode. Now how we will represent cell? Alphabetically, anode and cathode, anode comes first. So first we will write anode. Then it comes salt bridge. Then we will write cathode. Like this we represent the cell. First we will write alphabetically, A comes first, anode. Double line is salt bridge, then cathode. So which reaction is taking place at anode? Zinc is converting into zinc ions. So you can write zinc/zinc ions. That is a reaction taking place at anode. Then salt bridge. At cathode, copper 2 plus ions is converting into copper. So you can write copper 2 plus to copper. So like this we are representing the cell when the equation is given. If concentrations are given, you write in bracket with the ion, but otherwise we will write it like this.
Mom, can you repeat what those two lines indicate?
These two lines indicate the salt bridge. Salt bridge.
Okay.
Now I am writing one equation. All of you just represent in the cell representation form. This is the first equation. We are not writing any stoichiometric coefficient in the cell representation. Pradhani, you tell me the first one.
Mom, Cu is gonna be the anode and Ag is gonna be the cathode, right? Mom, so it's gonna be Cu/Cu2 plus, then salt bridge double line, and then Ag plus, and then Ag.
Yeah. Correct. Now next one, this one was cathode. Arjun, you tell me the next one.
Ma'am, nickel is anode and Ag is cathode. Will be Ni/Ni2 plus and then Ag plus and then Ag.
Good. Nickel to nickel 2 plus is anode, salt bridge. Ag plus to Ag is cathode. So like this, you have to represent the cell. First, you check which one is anode and cathode. Write anode first, salt bridge, then cathode. Now, the second thing, if cell representation is given, how to write the equation? Because both the things you should know for the numericals. Let us suppose they will give you, okay, this is the cell representation, Ni to Ni2 plus salt bridge to Ag plus, sorry, Ag plus to Ag. This thing is given and you have to write in the equation form. See, don't write it directly. Okay, nickel plus Ag plus gives nickel. Write that first half cell equations. Half cell means first we write the anode equation. Here the anode equation becomes, because nickel is converting into nickel 2 plus. So you can write nickel converts into nickel 2 plus by losing 2 electrons plus 2 electrons. Plus 2 electrons. First you write the anode equation. Then in cell representation, the second part is cathode. Then you write cathode equation. At cathode, Ag plus is converting into Ag. So Ag plus 1 electron. Always when you have to write the equation from cell representation, first write both the equations, then you have to add it. Gives Ag. Now I will tell you why you have to write the half cell equations first. See, when you are adding the two equations, make sure that the number of electrons are same in both the equations. You can see here anode has 2 electrons, silver has 1. So before addition, you have to multiply the second equation by 2 so that the number of electrons are same on both the sides of the equation. So it should be nickel. You have to add left side to left side, right side of the arrow to the right side. Nickel plus 2 Ag plus, electrons gets cancelled, gives you nickel 2 plus 2 Ag. This you have to represent the cell. Nickel to nickel 2 plus 2 electron, Ag plus electron gives Ag. Then you add it. First you make number of electrons same, then you will add it. Giving you the cell, you have to write the equations. Mg2 plus the second one is now convert these two cell representation into equation. If you have a doubt, ask me, or if no, you can write it.
Oh, ma'am, now it out.
Done?
Now it out.
Tell me.
Ma'am, the equation you like wrote before, right? The Ni, won't it be minus 2 electrons in nickel?
Here.
Yeah.
No, nickel, how nickel will convert into Ni2 plus? By losing
By
2
losing-
electrons, right?
Yeah.
So 2 electrons are like you can say removed from the nickel. So it should be nickel 2 plus 2 electrons.
Yes, ma'am. Ma'am, even an Ag then?
Ag plus is converting into Ag. So it means Ag plus will gain how many electrons to convert into Ag?
All right.
1. So in second case it is gaining, so that's why plus electron. In first case it is losing, so that's why plus in the right side.
Yes, ma'am.
Did you try the magnesium one?
Mom, did you ask me?
Yeah.
3 mg plus
Hmm.
2 Cr3 plus will give 3 mg2 plus 2 Cr.
All of you get the same. In this case, when you are writing the
Shouldn't be 2 here.
oh sorry, yeah. 2C. At anode, when you are writing, it becomes Mg to Mg2 plus because it converts into 2 plus, so it loses 2 electron. At cathode, Cr3 plus is converting into Cr, so it will gain 3 electrons and converts into Cr. So when you have to add it, we have to make the number of electrons same. So this gets multiplied by 3 and this gets multiplied by 2. So you will get the same thing. 3 Mg plus 2 Cr3 plus gives 3 Mg2 plus 2 Cr. 6 electrons get cancelled. Shivani, you try the fourth one.
Yes. Am I supposed to for each for anode and then for cathode?
If you are done with the overall equation, tell me overall. Otherwise, you tell me anode cathode separately. Anything is fine.
I'll tell anode cathode separately. Al yields Al3 plus 3 E minus. And then for cathode, Fe2 plus 2E minus, between 2 electrons, yields Fe.
Yes. So
And then I multiplied the first one with 2 and the second one with 3.
Hmm.
And I added it and I got 3 Fe3 plus. Plus 2Al yields 2Al3 plus plus 3 Fe.
very good. Yeah. So like this, you have to write the equation. Pradhanya and Arjun, just check you have done it correct, both the equations.
Yes, ma'am. Same
Yes, ma'am.
equations.
Arjun, now no doubt in electrons
No,
part.
no, ma'am.
Okay. Fine. So this is all about the cell representation. If equation is given, then how to write the cell representation, and if cell representation is there, how to write the equation. Now next topic we will start, that is the electrode potential and EMF of the cell. 1 second, I will restart my board. Write down the heading, electrode potential and EMF of the cell. Aditi, you tell me what is electrode potential?
And the potential difference that needs to be applied across the two ends so that the current will flow.
So we can say that is EMF, which you have told, that is the EMF of the cell. What is electrode potential? It is tendency of the electrode to lose or gain electron, or you can say to undergo oxidation or reduction. So electrode potential is the tendency of electrode to undergo reduction or oxidation. Tendency to reduce is reduction potential. Tendency to oxidize is oxidation potential. There are two types. And what is the relation between reduction and oxidation potential? It is the sign will change. Reduction potential is equal to negative of oxidation potential. I will tell you what is that. Electrode potential is the tendency of electrode to lose or gain electrons. To gain or lose electrons. That is the electrode potential. It is of two types, reduction potential and oxidation potential. Reduction potential is tendency to reduce, tendency to gain electron, tendency to undergo reduction. Gain electron. And oxidation potential is tendency to oxidize. It is tendency to undergo oxidation. Oxidation means tendency to lose electron. So what is the relation between reduction and oxidation potential? Reduction potential is negative of oxidation potential. If in case reduction potential is given, you have to convert into oxidation potential, only the sign will change. Let us suppose oxidation potential of zinc is 0.76. So the reduction potential of zinc becomes minus 0.76. So the electrode potential is the tendency of the electrode to reduce or oxidize. To reduce is reduction potential, to oxidize is oxidation potential. But in this chapter, mainly we will do the reduction potential. Everything we will represent in terms of reduction potential. For MCQ, there is one more important point. On what factors electrode potential depends? Electrode potential value depends on first is nature of metal and its ion. Second, temperature. Third, concentration. Nature of metal and its ion. Which metal we are using? Second, temperature. If we change the temperature, the value of electrode potential will change and the concentration of the ions. If we change the concentration of ions in the solution, the value of electrode potential will change. So that is about the electrode potential. And remember one point, all the every time we represent the half cell reactions always in terms of reduction potential. We use always reduction potential for calculating the EMF, for writing the values in the electrochemical series. Everywhere we use the reduction potential value. Now next thing is, what is EMF? Pradhanya, you know what is the full form of EMF?
Ma'am, electromagnetic force.
It's not electromagnetic, it is electromotive force. EMF is electromotive force, or it is also called cell potential. What is EMF? EMF is the difference in the potential between the two electrodes. Between the two electrodes, what is the potential difference? That is called EMF. But there is one condition here, when the circuit is open, when there is no current in the circuit. So it gives you the maximum value of the voltage obtained from the cell. What is EMF? It is a potential difference between the electrodes. The condition is, underline this condition, when no current flows through the circuit. In a circuit. So it means when no current is flowing in a circuit, so EMF is the maximum voltage which can be obtained from a cell. So it is the maximum voltage obtainable from a cell. EMF is the difference in the potential across the electrode, but the condition is when no current is flowing through the circuit. So what should be the difference between EMF and potential difference? Potential difference is also the difference in the potentials of the two electrodes. But potential difference is when current flows through the circuit. This question sometimes come for 2 marks. What is the difference between EMF and potential difference? Both are the difference in the potential of the electrodes. But EMF is the maximum value because no current is flowing. Potential difference when current flows, so it is the less than the maximum value obtainable from the cell. It is also the difference of the electrode potential when current is flowing through the circuit. When current is flowing through a circuit. It is the first point of difference. Second point of difference is it is less than the maximum voltage obtained from the cell. Potential difference is value is always less than the EMF. It is less than maximum voltage obtained from a cell.
Ma'am, I don't know if it's just for me, but your screen is lagging a little.
Ma'am, for me too, it's very lagging.
It's lagging. Okay.
Yeah,
Give
Yes,
me
ma'am.
1 minute. I will share it again and check. Now you can see the whiteboard or it's loading it.
Ma'am, I can see it.
Okay, if it's still lagging, you just tell me, then I will switch back to that Google Meet. Maybe it was. Okay, so this is the difference in EMF and potential difference. So EMF is a difference, potential difference when no current flows. Potential difference is again the difference in the electrode potential, but when current is flowing through a circuit. The second point, EMF is the maximum voltage obtained. Potential difference is less than the maximum voltage obtained from a cell. Write down this, then I will explain the numerical part of EMF, okay, how to calculate.
So potential difference is the same as EMF, except in potential difference there's current flow.
Sorry, tell me Aditi again.
The difference between EMF and potential difference is that there's just current flowing in the potential difference.
Yes,
And EMF there's
when no current flows. So because current is flowing in the circuit, so it gives you the value less than the maximum value. But EMF में you are getting the maximum voltage. Is it done?
Yes, ma'am.
Okay. Now I will tell you how to calculate the EMF of the cell. EMF of the cell, because it is a potential difference between the two electrodes. So it is converted by E cathode minus E anode. What is E cathode? E cathode is the reduction potential of cathode. What is E anode? It is also reduction potential. Reduction potential of anode. No doubt cathode has reduction, anode पे always oxidation. But when we are substituting the values in EMF formula, we'll substitute the reduction potentials of both. In questions 99% they will give you only the reduction potential values. You have to just subtract it. But in 1% case, if they give you the oxidation potential of anode, then you need to first convert into reduction potential by changing the sign. And then you have to substitute it in the formula. So EMF is the potential difference, which is reduction potential of cathode minus reduction potential of anode. At cathode, there is a reduction, anode, there is a oxidation. But when we are calculating EMF, we are substituting only the reduction potential values. Now I will tell you how to check whether the value given is reduction potential or oxidation. Let us suppose this is the reaction. This is the reaction. So at this, if they are giving you E, they will write like this. E Zn2 plus 2Zn. It is equal to minus 0.76 volt. And in copper of copper 2 plus 2 copper, it is given as plus 0.34 volt. Now, how you come to know whether it is oxidation or reduction and how to calculate EMF? Now, first you check from the equation which one is cathode and which one is anode. Shivani, what is cathode, what is anode in the equation?
Ma'am, cathode will be the neg
Zinc or copper?
oh yeah, it'll be zinc.
Zinc, zinc pe there is oxidation or reduction?
Oh, it'll be copper.
Anode is oxidation. So zinc is oxidized, that is anode. Copper is reduced, that is cathode. So its formula is E cathode minus E anode. So cathode is copper. So first we write the reduction potential of copper. Here it is given Cu2 plus 2 Cu. Cu2 plus 2 Cu means it is a reduction potential value. So we can write it like this. Minus anode. Anode is zinc. Zinc is oxidized here. We have to check whether the value is for reduction potential or oxidation. It is given Zn2 plus 2 Zn. Zn2 plus 2 Zn means reduction. So the value given is reduction potential. We will substitute as it is. 99% they give you the reduction potential values. You have to just substitute. Only thing from the equation you have to check which is cathode, which is anode. In case they will write it like this. Like this, then it means they have given the oxidation potential Zn to Zn2 plus. Then you first convert into reduction potential. Then you substitute it in the formula. So they write it like this to check whether it is reduction potential or oxidation. Formula mein it is always reduction potential. When you solve it, you will get 1.1 volt. I will give you one more example.
Ma'am, can you repeat? Yeah, I don't understand this.
See, from the equation, can you check which is anode, which is cathode?
Yes, ma'am.
Copper undergoes reduction, so it is cathode. Zinc is anode. So EMF is equal to reduction potential of cathode minus reduction potential of anode. It means you have to subtract the reduction potential of copper minus reduction potential of zinc. So what is the reduction potential of copper given? 0.34. What is the reduction potential of zinc given? Minus 0.76. So you have to just subtract it. This I have explained. In case they will give you, instead of Zn2 plus to Zn, this value Zn to Zn2 plus. So it means this value is for oxidation or reduction potential?
Ma'am, this
Zn
is
to
for oxygen.
oxidation potential. So we need reduction potential value here. So what you can do? You can change the sign. It becomes reduction potential. Then you have to substitute it in the formula.
Understood, ma'am.
I'm giving you another example, then it will be clear to you. All of you write down one question. Calculate reduction the electrode potential of electrode potential. Whenever the electrode potential word comes, it means they are talking about reduction potential of nickel 2 plus to nickel if the cell potential means EMF, cell potential of nickel to nickel 2 plus, copper 2 plus to copper is 0.59 volt, and it is given that E naught of copper 2 plus to copper is 0.34. E of copper 2 plus to copper is 0.34 volt. Electrode potential always we represent in terms of volt. Now read the question, try to solve it. Calculate electrode potential of nickel 2 plus to nickel if cell potential of this cell is 0.59 volt, copper 2 plus to copper electrode potential is 0.34.
Ma'am, will it be minus 25?
Minus 0.25.
Yeah,
Just check.
0.25.
Correct. What is the unit, Arjun?
Volts.
Volt. Yeah. And in this case, what is cathode? What is anode?
Cathode is Cu and anode is Ni.
Yes. And what is the value of EMF?
0.59.
Cathode is Cu. What is the value of electrode potential, reduction potential of copper?
0.34.
And what you have to find? Reduction potential of nickel. So you can find nickel by subtracting this. (0.34 minus 0.59, which is minus 0.25. volt. Because the reduction potential you have to find, and reduction potential only is given. So you have to just substitute the values. Shivani, any doubt here in this numerical?
No, ma'am.
Aditi, for you also this point is clear? How to calculate EMF?
Yes, ma'am.
Okay. Now I will just complete this topic. There is one thing here which is known as standard reduction potential or standard electrode potential. Now next topic here is, that is also a theoretical topic. After this, from the next class, numerical part will start. Standard electrode potential. Electrode potential, all of you know what is that. Electrode potential is tendency of the electrode to undergo oxidation or reduction. Now, what do you mean by standard reduction potential or electrode potential? Tendency of electrode to undergo reduction or oxidation under standard conditions, when the conditions are standard. What do you mean by standard condition? Temperature should be 298 Kelvin, pressure should be 1 atm. The main thing is concentration should be 1 molar. So these are the standard conditions. So if these conditions are there, what is the value of electrode potential? That is standard electrode potential, and it is represented by naught. We are writing E naught. This naught represents standard conditions. So whenever naught is written, it means the concentration is 1 molar, temperature 298, pressure 1 atm. Now, how to calculate experimentally, how to calculate the standard electrode potential of all the metals? To calculate that value, they have fixed one electrode as the standard electrode, which is a hydrogen electrode. They fix hydrogen electrode as a standard hydrogen electrode as a reference electrode. Reference electrode means they have fixed its electrode potential value 0. Standard hydrogen electrode is taken as a reference electrode, and they have assumed that its value is 0. And when we compare the other metals with hydrogen electrode, you can get the value of standard electrode potential of the other metals. I will give you one example for that. First, I will tell you what is the construction of standard hydrogen electrode. It is represented by SHE, standard hydrogen electrode. So in a beaker, you have 1 molar HCl solution, because it is a standard condition, so concentration should be 1 molar, and platinum foil is dipped in that. It is a platinum foil enclosed in a glass tube. This is a glass tube, and here we will pass hydrogen gas. The pressure of hydrogen gas should be 1 atm. Now that is the construction. Now question is, what is the function of platinum foil here? There are two things. One thing, platinum foil is neutral. It does not react, and it provides the surface area for the reaction. Hydrogen gas gets absorbed at the surface and then it reacts. So it provides the surface area for the reaction. That's why we are using the platinum foil. 1 molar HCl solution, platinum foil is dipped in it, and from the outer tube we will pass hydrogen gas. This simple standard hydrogen electrode can act as an anode as well as cathode. And this standard hydrogen electrode act as cathode. If it act as an anode, then it undergoes oxidation. H2 gas converts into H plus and 2 electrons. It gets oxidized. Hydrogen gets oxidized to H plus ions. And if it act as cathode, then H plus ions, the H plus ions in the solution, HCl wale H plus ions, it will take up electrons and it converts into hydrogen gas. Reverse reaction. So this standard hydrogen electrode, it can be act as cathode, it can act as anode also. It is a reversible electrode and its electrode potential value is assumed as 0. Next thing I will tell you how we can calculate the electrode potential of other metal with respect to this. This is the construction of standard hydrogen electrode. Now, the second thing, if you have to find, let us suppose this is an example. Let us suppose I have to find the electrode potential value of zinc. Standard electrode potential value of zinc. How we can do that? I will combine zinc with hydrogen electrode. This is 1 molar zinc sulfate. Don't write it, first listen carefully this point. This is just a theoretical point. 1 molar zinc sulfate. This is zinc electrode. Here this side is the hydrogen electrode. Platinum foil. 1 molar HCl. Hydrogen gas is passed. Both the electrodes are connected with a wire and a voltmeter, and both the solutions are connected with a salt bridge. We have to, because we have to find the standard reduction potential value of zinc, so we combine it with hydrogen and then we can calculate. Now you know that zinc has more tendency to oxidize, so in this case zinc is anode and hydrogen is cathode. Now EMF is equal to E cathode minus E anode. E naught of cathode minus E naught of anode. Where you get the, from where you get the value of EMF? From voltmeter. Let us suppose in this case the voltmeter shows the reading of 0.76, which is the EMF of the cell. E naught cathode, cathode is hydrogen, its E naught value is 0. You have to find the value of E naught of zinc, reduction potential of zinc. So you will get it as E naught of Zn2 plus 2Zn comes out to be minus 0.76 volt. This is the reduction potential value of zinc. In the same way, we can calculate for all the metals the reduction potential values of all the metals. If you combine it with copper, voltmeter gives you the value of EMF, hydrogen is 0, you can calculate for all the metals. And then we arrange all the metals in the decreasing order of the reduction potential values, and that series is called electrochemical series. Now let us suppose I'll give you one more example, copper. We have to find the standard reduction potential of copper. Copper has less tendency to oxidize. So in this case, hydrogen becomes your anode. This is 1 molar HCl. We pass hydrogen gas. They are connected with here copper sulfate solution. Connected with a wire having voltmeter and key. And both the solutions are connected with a salt bridge. Now in this case, again the same thing. EMF value you get from voltmeter, which is E cathode minus E anode. Let us suppose EMF value is 0.34. In this case, your cathode is copper, which you have to find reduction potential of copper, and anode is hydrogen, so which is 0. So E naught value of copper comes out to be 0.34 volt. So like this you can calculate for all the metals, and then we arrange all the metals in the decreasing order of the reduction potential values, and that series is called electrochemical series. Now note it down, then I will dictate one line. This completes one topic, standard reduction potential. And tell me if you have a doubt, I will explain that point again. This is the experimental way to calculate the standard reduction potential values of all the metals. Arrangement of all the elements in order of increasing reduction potential value is called electrochemical. In book there is one big table given, that is electrochemical series. No need to learn any values always they will give you. Only hydrogen value you should know, it is 0. So with this experimental thing we calculate for all the elements and then we arrange it in the decreasing order. So that is known as electrochemical series. Once you are done with the writing part, tell me. I will explain 1 or 2 numericals based on that. All of you are done with the writing part till electrochemical series.
Yes, ma'am.
Okay.
Mom,
Now,
just give me 1 minute.
Pradhani, you are done with the previous part, or shall I show that part again?
No, mom, the previous part I'm done. I'm done.
Okay. Now, this is just an example I will give you. Okay, these are the 3 reduction potential values given to you. Let us suppose we are making a cell with silver and zinc. From the reduction potential values, can you tell me which will reduce and which will oxidize? Because always one will reduce and another electrode will oxidize. So if I am combining zinc and silver, Arjun, you tell me, according to which should reduce and which should oxidize? Or you can say what should be cathode and what should be anode?
Anode will be the Z and
And cathode will be the
AG.
silver.
AG.
Why so?
I don't know why.
From the, like how you guess that okay, this is anode, that only zinc is anode, silver will be the cathode. But why? What is this value given? These are 0.80 points minus 0. These are the values for the reduction potentials, right? So silver ka reduction potential is 0.80. Zinc reduction potential is minus 0.76. So out of these two, which has a more tendency to reduce? More the reduction potential value, more tendency to reduce.
So
which
silver.
one? Silver. When you combine silver and zinc, because the reduction potential of silver is more, it should reduce. And reduction always takes place at anode or cathode?
Cathode.
Cathode. So that is the reason silver is cathode here, zinc becomes anode. So from the values of E naught, that is the advantage of electrochemical series. Okay, from the values of E naught, you can check which one is cathode and which one is anode.
Yes, ma'am.
Let us suppose I am combining silver and copper. Do you explain in this case what should be the cathode, what should be the anode, if these two values are given?
Again, AG will be cathode and then
Yes.
C will be
Anode. Riti, is it correct?
Sir, AG will be the cathode.
Ag will be the cathode, copper will be the anode. Why?
Because reduction at the cathode. So, because it has the higher reduction potential.
Yes. More the value of reduction potential, more tendency to reduce, and that becomes a cathode. So when you combine silver and copper, silver becomes cathode because it will reduce, copper will oxidize, it is anode. So E naught values help to check which one is cathode and anode in the cell. So in next class, we will start with the announced equation. We'll just revise one. We have done today so many small topics. Just revise.
Can you repeat again? Why is it like anode and cathode? Like,
see, these two electrodes we are combining, right? So which has more reduction potential values? Silver or copper?
silver.
So more the reduction potential value, more tendency to reduce. So which will undergo reduction?
AG.
Like reduction always takes place at cathode. Right?
Understood, ma'am.
Oxidation at anode. So silver is cathode, copper is anode. Okay, now we will revise once what we have done today. Next topic I will not start now. First thing, what is electrochemical cell? Pradhan, I will start from you. Tell me what is electrochemical cell? Is it for spontaneous, non-spontaneous? What is the value of delta G? And signs for anode cathode. Tell me all that points.
Electric chemical cells are cells that convert chemical energy into electrical energy. And it is spontaneous reaction, and delta G is less than 0. And anode's negative and cathode is positive.
Yes. Electrochemical cell, chemical to electricals for spontaneous reaction, delta G negative and anode negative, cathode positive. Shivani, you tell me.
Delta G.
Delta G is Gibbs free energy change, and which measures the spontaneity of the reaction. Spontaneity means if the reaction is spontaneous, delta G value comes out to be negative. If reaction is non-spontaneous, its value comes out to be positive. So delta G is Gibbs free energy change. Shivani, you tell me what is the function of salt bridge in the electrochemical cell?
Salt bridge is basically, it first maintains the neutrality maintains the neutrality of solution in both the containers. It's a U-shaped tube, basically.
It's
It
a
either
U-shaped.
contains KCl or KNO3
Yes.
and some agar jelly.
Agar jelly. That
Agar-agar.
function is just to make it semi-solid, but it has
It also
KCl or
completes the circuit.
right. Now, third point, Arjun, you tell me, if we apply, let us suppose the cell potential of the cell is 1.1. If we apply external voltage of magnitude equal to 1.1 volt in the opposite direction, what happens to the direction of current?
Equal 1.1.
Yes.
There's no current.
If it is greater,
And then it'll flow on the opposite side.
what should be the opposite side? Which to
Cathode or no, anode to cathode.
anode to cathode. Yes. Now, next question is, Aditi, you tell me how to represent a cell. Which thing will write first and
The anode in the reactant, then the anode in the product, salt bridge, cathode in the reactant, and cathode in the product.
yes. So first anode, salt bridge with the parallel line, then we write cathode. Aditi, you tell me what is the difference between okay, what is just electrode potential? What is the relation between oxidation potential and reduction potential?
Electrode potential is the tendency to gain or lose electrons. Reduction potential is the tendency to undergo reduction. Oxidation potential is tendency to undergo oxidation, and reduction potential is negative of oxidation potential.
Yeah. Pradhani, on what factors the electrode potential value depends?
On nature of the metal and its ions, then temperature and concentration.
Yes. Arjun, what is the difference between EMF and potential difference? What is the difference between EMF and potential difference? Okay, tell me what is EMF?
Ma'am, the potential difference between the electrodes and no current.
And potential difference? Same thing, but when?
Just flowing through circuit.
When current flows through the circuit. And EMF is the maximum voltage obtained, and potential difference is?
Minimum voltage. No, less than maximum.
Less than maximum voltage obtained. Shivani, how we can calculate EMF of the cell?
EMF of the cell can be calculated by the difference between the reduction potential of the cathode and the reduction potential of the anode. Yeah.
Yes. Reduction potential of cathode minus reduction potential of anode. Aditi, what is the value of standard electrode potential of hydrogen?
0.
And what are the standard conditions?
STP, so 298 Kelvin, 1 atmosphere, and concentration is 1 mole.
Pradhanya, last question. What is electrochemical series?
Ma'am, arranging all elements in decreasing order of reduction potential value is known as a electrochemical series.
Yes. When we arrange all the elements in the decreasing order of the reduction potential values, that is electrochemical series. Arjun, let us suppose I'm giving you two metals. One has reduction potential 0.92, another has reduction potential minus 0.25. Which will be cathode and which will be anode?
0.92 will be cathode.
And minus. Okay. Shivani, let us suppose I'm giving you two metals. एक का reduction potential है 1.25. The second one, oxidation potential is minus 0.76.
Reduction would be minus 0.7.
Okay, I will write anode. There is one metal A its reduction potential is 1.25. This is the reduction potential value. And B ka oxidation potential is given, which is minus 0.76. This is oxidation potential. Which will oxidize,
One
which will
second, the
reduce.
screen is lagging.
Here.
Okay. Oxidation will be for air, anode, right?
Why?
I mean, it's because it's higher value.
See, but this is the oxidation potential. First, you convert into reduction potential. Then you compare. What is the reduction potential for B?
Plus 0.76.
0.76. So, which has high reduction potential value?
The first one, A.
So, it should be cathode, and the second one will be
Anode.
anode. So, if oxidation is given, first you convert into reduction, then compare. More the value, more will be the tendency to reduce and cathode.
Okay.
Last, Aditi, last question for you. For a reaction to be spontaneous, this we have not discussed, we have to apply the logic. For a reaction to be spontaneous, what should be the value of EMF? It should be positive or negative? Reaction to be spontaneous.
And is it negative?
It is E cathode minus E anode. Reduction potential of cathode minus reduction potential of anode. So cathode pe always there is a reduction, its value should be higher.
Yeah.
Anode ka reduction potential value always should be lower. So EMF should be
Positive.
positive. So if the EMF value is positive in a reaction, then the reaction is always feasible. If EMF is negative, reaction is non-feasible. So this you have to revise thoroughly. There is no numerical, nothing much is there in this topic which we have covered. So revise it. In the next class, we will start the Nernst equation. That is the main thing in this chapter, from where 1 3-marker question definitely comes in board exams. But revise this thing. This is a base. What is redox, reduction, oxidation, everything you have to revise. Any doubts? Shall we wind up?
Yes, ma'am.
Yeah. Thank you.
Thank you.
Thank you, ma'am.
Yeah.